Good morning, everyone. Welcome to Code Rage 2019. This is my session about writing UDFs in Delphi for Interbase. My name is Olaf Monian, and I'm the CEO of Developer Experts, and I am a Embarcadero MVP. If you have any questions, just drop me an email at olaf@monian.net. All right. For the demos, I'm going to show you, I'm using Interbase 2017. Basically, one of the XE versions should work as well. And even most of the stuff I'm showing should work in Firebird. But this is only Interbase, or actually I only tested on Interbase what I'm going to show you. All right. UDFs. UDFs are the so-called user-defined functions in Interbase. They are similar to what you probably know from stored procedures. The difference is that instead of writing stuff in SQL and execute it and execute the SQL somehow in the database backend, we are actually loading functionality from DLLs, from Windows DLLs. Of course, what we do here would even work on Mac OS and Linux, but I didn't run any of the code through one of those platforms. So for now, we are working on Windows and we are talking about DLLs. On Linux, it would be dynamic libraries. In Interbase, UDFs are typically used for calculations. So string calculations, mathematically calculations, whatever. So they are not really supposed to be used for business logic. I'm not even a big fan of writing business logic in stored procedures in databases. That's something I really discourage using or doing, because a database for me is a container for data. That's it. And the UDFs are excellent if you have problems in terms of whatever processing strings in your queries or something. Then that's an excellent technology to actually improve that and bring in your own algorithms there. But it should be on the non-business side of your code. All right, so, well, let's go into Delphi now. All right, actually, before we are going into Delphi, let's have a look at a sample database in Interbase. So this is basically the famous employee database that comes as a sample with Interbase itself. So there are a couple of tables in it, or actually several tables. And well, we have, for example, a customer table. Just let's work with that one. Okay, that works. So we are connected to the employee database. So I actually already have a UDF here, or we actually, as you can see, we have two UDFs in that database. Just let's have a look at the first one. So let's select Hello World, one from RDB database. RDB database is a system table that returns a single record. So in that case, we just select from that one and we get back the result from the UDF Hello World with a parameter of 1. So as you can see, if we put in 2 in here, we would get not 42 but 84. So it's a simple calculation that's performed in that Hello World thing. So how's that defined? So I do have a drop because it already exists, so we are dropping that one. And then we have a declared external function, hello world. Okay, that's fine. It takes one single parameter of type integer, and it will return an integer value, and we are returning that by value because we are, well, sending back the actual value, not a reference to a value, just the value. Okay, that's fine. So, and that UDF, that function is defined in that very DLL. So we are referencing to an entry point named hello world in a module named dxudf.dll. Okay, if we execute that, it basically says 0 rows affected, so that worked, and we have the hello world function. And here I'm actually using Database Workbench, which is a nice tool. It says we have hello world taking one integer parameter and it's returning another integer. And well, you already saw that just works. Okay, so let's go to Delphi and see how that is actually implemented. Okay, we are in Delphi, that's 10.3. And to create a UDF, you create a DLL. So in Delphi, it's a library. So a library creates a DLL as output, and Interbase is, well, it's a modern database if you want, and that's going to be in 64-bit. So if you install Interbase on a modern system, which is usually 64-bit, it will be 64-bit. So that means we have to develop our DLL in 64-bit because the Interbase server only can load 64-bit DLLs. Okay, so it's a library project, and the first uses should be system.simplesharemem, even if we really don't use that in that project. But if you are producing DLLs, and there's always a chance that you are going to share memory between the DLL and the executing process, you should use a shared memory manager. There is still a lot of documentation out there in the internet that says, oh yeah, if you do that, you should really use the shared MM in Delphi. Well, that's the old one. You really don't want to use that one. Use simplesharemem. That's the one that works actually with fastmm in the background. Fastmm is the memory manager, which is the default in Delphi since, I believe, 2009 or so. I'm not exactly sure, but for a long time we have fastmm in Delphi. So use simplesharemem as a first line in your user statements. So that's something I really wanted to point out here. And here we have an export section, and we are exporting a function called hello world. All right, I have a unit called DX, well, developer experts, Interbase, UDF, and some miscellaneous functionalities. So we have a function hello world declared, and the input variable is of type integer, and always use the var keyword here because the input is always by reference. That's important. And we are returning an integer. Okay, that's fine. And make sure that you use the C declaration calling convention. The C declaration is almost the same as a standard call convention that you probably have seen in many of those UDF documentation entries in the internet. There is basically just one difference, and the difference is the responsibility of who is going to clean up the stack. And Interbase, in fact, uses C declaration. So if you have a mismatch here and use standard call as convention, then it will certainly work for a while, but there is a risk that you run into errors at a certain point because your stack might be corrupted or cleaned up incorrectly. So just make sure you're using C declaration here. And then, of course, you have to mark it again as export. So your function hello world is now exported by the DLL we are producing here. All right. So, and this is, well, this is all. This is my function. I'm taking an input, an integer. I'm doing some very complicated calculation here, the answer to everything multiplied by the input. All right, that's all. That's really the whole magic, how to create simple functionality in your UDF DLLs. All right, so let's go back to, or let's actually look how to or where to put that DLL. All right, so Interbase, I use a developer license, and that developer license comes with Delphi, so you can actually choose to install Interbase with a developer license with your Delphi installation. That's basically an installation option of Delphi itself. And if you do so, you basically get Interbase 2017 directly under your installation directory where you put Delphi. Okay, so, and here there is a bin directory and everything, and there is a subdirectory called UDF. That's the standard setup of Interbase, and there all your DLLs go. Okay, so go to your output directory. So that's where I actually put my DLLs, or where I produce the output. So this is the compiled DLL that I produced from the code that you have seen. And this is the RSM file. This is the remote symbol file, which is required if you would like to debug into your DLL. Okay, so I'm still in debug mode, so that's the reason why I got the remote symbols file here. And you just copy that over here. And again, the RSM file is only needed if you want to debug the DLL from Delphi. Okay, so that's basically it. Now, when we go to any SQL tool that connects to Interbase, then you create that declaration, and once you hit that UDF that you declared over here, it will actually, or the Interbase process will actually load that DLL, and that's the reason, or the declaration is then used to look up the entry point in that DLL. So the actual, and you see it still works, and the actual declaration that you do here, it does not yet load the DLL. So if that would even work with no DLL in the UDF parse. Okay, so that's fine. Just one word about how to start and debug Interbase. I will set up another session, a short session about how to debug from Delphi into Interbase, into the DLLs. All right, so for this short demo here, there's not enough time for doing that. Okay, that's the first thing. The second one I have prepared is, again, we have the customer table here. There's contact last. You see there is brown, bottle, bucket, and there's this Muller. And let's try what happens if you select upper contact last from customer. And you see, if you look closely, the this Mr. Muller has a U umlaut, which is one of those fancy characters we have in Germany. And if you look closely, that U umlaut is not really in uppercase, because the upper function only works on the first 127 characters that are in ANSI strings. So it doesn't really do any uppercase functionality on the special characters. So this is the idea, the motivation why we would write something in Delphi to, create our own uppercase function, which works on special characters as well. So, drop that one. And here's the declaration I'm using, or I'm going to declare a function uppercase, all right? It takes a C string as parameter. C string is the only type which you can use to declare UDFs working on strings. Okay, that's an internal data type only used when working with UDFs. You have to say, or you have to declare the length of that string. We are just taking 200 here, and it's gonna return another C string. Of course, we need a result that's gonna be 200 again. Then there is a mysterious free it, whatever that is. I'm gonna talk about that in a minute. And there is, of course, an entry point, uppercase again, and that's it. All right, so let's execute the declaration again. Works, so 0 rows affected. That did work. And now run that uppercase, our own uppercase function on that table. And you see, if we look closely, the U umlaut is now in uppercase as well. So that worked. So let's have a quick look at the Delphi code behind. So we have uppercase input. Input for, or the data type where you declare that as C string in the UDF declaration. On the Delphi side, it's always going to be P and the car. It's always P and the car, nothing else. That's the only data type that works, right? And again, it's C declaration as calling convention, and of course, it's an export. Okay, you don't need var here because these are actually pointers, and they are always taken as a pointer type as a reference. So, or actually, it's not a the memory behind is referenced by the pointer, which is given as a value type, technically. All right, so let's have a look at the actual implementation. Okay, we take the input, so we are actually converting the P ANSI car into an ANSI string. So we can work with that in Delphi now. And well, I want to use system sysutils uppercase. So this is a standard function in Delphi. I'm just taking that input, which is an ANSI string, and I tell the function, the uppercase function, to use user local as a parameter, and that means that's the local options. And if you put that parameter in, it will actually work on special characters as well. That's what we wanted. So we get as a result, which is still which is gonna be an ANSI string. And of course, uppercase itself works on regular Delphi string, so we are converting that back to an ANSI string. Well, because the input is ANSI string, the result of the uppercase operation can only be ANSI string as well. So this is all fine here. And now there is a mysterious line. What we return is basically a pointer to some memory where we store a string, okay? And we return a pointer to some memory. So we have to allocate this memory. We could use a Delphi function that creates a pcar, and it would perform everything that we needed. But the problem is, if we create memory in that DLL, who's gonna take that memory and free it again? So there are code examples out there in the wild that just create a string or the memory for that string, and they don't care about who is taking care of freeing that string or that memory again. So you would actually create memory leaks if you don't care about that memory. So string to interbase string, that's a function that I wrote, and that's doing some magic. It takes an ANSI string, because that's what we are working on. The employee database, the sample database, is in ANSI string. It doesn't know about Unicode, okay? So it's just ANSI. And string to interbase, that's something that I wrote. I put that into DX Interbase sysutils. And there is some magic code. So this is the function. It basically allocates memory. So it takes the length of the input, which is an ANSI string, and adds 1. We need the closing 0. It's a P ANSI car needs a closing 0, so we need 1 byte more. And interbase util m alloc. Okay, that's a function that we actually take from IB util 64 DLL. This DLL is part of Interbase. It contains access to the memory manager of Interbase. So we tell Interbase, oh, we need some memory. Well, create that memory or allocate that memory for us and give us back a reference to that memory. That's basically what this function does. The reason we do that is we can then tell Interbase, okay, here's a string. It is created in a memory location that you created for us, that you allocated for us. Now take care and free it again. And of course, Interbase can only free memory that it allocated before. So this is the reason why we have to use this mysterious IB underscore util 64 DLL. This DLL is part of Interbase. You can actually find that in here in the bin directory. It's somewhere here in the bin directory. You see, there is that DLL, and Interbase will of course find that DLL. You don't need to give any pass. You don't have to copy that DLL into your Windows directory or something. It's just there. It's fine keeping it there. So go back here. And here I just create or let Interbase allocate that memory. And now I'm taking that and copy basically our string that we already filled with an uppercase version of our original string. And I'm copying the content of that string into the memory that Interbase allocated for us. Okay, so we go back here, and the result is then a piece of memory allocated by Interbase with the contents of our operation. That's basically it. So that's the way it works. Now, the problem that we are facing next is a little bit more complicated even, or actually one piece that I forgot about. This free it after the return parameter tells Interbase, oh, what you get back here is memory that you are going to be responsible for freeing it when you are done with it. And that's where it connects everything. So make sure you have free it and only call free it on returned memory that Interbase created for you, allocated for you. That's important. So only memory that you created using that function, you can actually tell Interbase to free when it's done. Okay, so that's the whole thing here. Okay, I already mentioned I'm working with the employee database. That one is not using, it's not prepared for Unicode, so you can't put Unicode in here. So to show you how to work with Unicode, which is a little bit more complicated, is I created a test database. This test database only has one table, a very simple one. Okay, so we have a customers table, and let's have a quick look at the customers table. Select asterisk from customers and execute that one. And here we go. And you see I created a table containing one field was just ANSI characters and some special characters, which would still be in the ANSI code page. And now we have some Russian text, Russian characters here. This is hello world in Russian language, in Cyrillic characters, which require obviously Unicode to be displayed. So again, in that database, I also have my uppercase function, and it's basically almost the same declaration. The only difference is I'm pointing the uppercase function in that database, in that test database, to uppercase UTF-8, okay? And it's again 200 characters. Internally, you can see that here, Interbase takes the 200 and multiplies them by 3, because this database is set up to use Unicode _FSS, which is an alias for UTF-8. And well, they just basically calculate that there is an average of 3 bytes per character. So it's just an average number of bytes per character. It could vary from actually 1 byte to 4 or even more. So if we want to store 200 characters, it could be that we need a few more bytes. That's the reason why internally Interbase makes a 600 here. Okay, so I got that uppercase function. Let's try that again. So just make an uppercase from test. Yeah, that works. And now let's make a selection from select uppercase. That's gonna be name from customers. And here we go. Execute that. Takes a moment to actually load that. And here you see, we got the German umlauts in uppercase, and we got the Russian hello world text in uppercase. Even though this is UTF-8, you can imagine there needs to be some extra treatments, and let's have a look how that works. In that MISC unit, I have a function called uppercase UTF-8, and surprise, it's still declared as ANSI car. The reason is ANSI car is basically just a wrapper or alias for bytes. That's the whole thing. That's the way Interbase works with the strings. So we still get something in ANSI car. That's important. You don't put a P car in here. You still use P ANSI car. Okay, let's look at the implementation. Okay, so what we get here is now something, because the database is internally using UTF-8, we now get a byte array, a byte collection where the actual string is encoded in UTF-8. So to work with that string, we have to decode it from UTF-8. Decode from UTF-8. So decode from UTF-8 is a function that I wrote. And what I do here is I take the input, which is an ANSI car, of course, and I create a T array of byte, set its length to the length that we get here. And then what I do is I copy all the bytes in that ANSI car, in that P ANSI car, into my byte array. Okay, so that's a copy operation, and then I can pass that array into the T encoding UTF-8 get string function, and that returns a string, a regular Delphi string, decoded from whatever there was in that UTF-8 string that Interbase handed out to us. Okay, So at this point, we have a decoded string which is readable. And then what we do is we run our regular uppercase function on that one, on the decoded input. And what we get returned is a regular Delphi string again. And here we do pretty much the same thing as we have done before, with the exception that we have to encode our result in UTF-8 again. So string to IB string, I'm not passing in an ANSI car, I'm passing in a string now. And that's how the function knows it's an overload actually. So we are not passing in the ANSI string, we are passing in a string. And that one now takes the input, encodes the input into UTF-8 so that I have the an UTF-8 encoded collection of bytes. I take the length, and now of course I know how many bytes I have. I again allocate memory. I take that memory, treat it as a p-ANSI car. That's what's happening here. I'm just taking that memory and treating it as a p-ANSI car. And then I can just copy the bytes that I have now in here into the result. The result, remember that? That's a freshly allocated piece of memory by Interbase. So I'm copying the bytes that are encoded into UTF-8. I'm copying that over into the ANSI string, and that's it. And I'm actually, putting a 0 at the end of the whole string. That's what the last line does. And that's it. So if you do that and return this array of bytes, which it is actually, and return that as an p-ANSI car, then Interbase knows how to do or how to actually display that. And this is what's happening here. So we are getting back an uppercase version of the UTF-8 encoded string, which we are decoding, uppercasing, and encoding again and returning to Interbase. And again, here is the free it. So Interbase knows, oh yeah, it's memory that I created, I have to free it. And that's the whole magic. Okay, so this is pretty much it. If you have any questions, send me an email. The code is in a Git repository. I will just show you the location at the final slide. Thank you very much.